Hi everyone! Welcome to my class. I am Miss Ingilio and I will be your teacher in science. In this lesson, you will learn the different factors that affect potential and kinetic energy. You will also learn to differentiate kinetic energy and potential energy. And also, you will learn to calculate for kinetic energy and potential energy. Before we identify the difference between potential energy and kinetic energy, let us first identify what is energy. Energy is the ability to do work. It is the ability of an object to perform a certain work. Energy is measured in joule. Now, why is energy measured in joule? That is because of James Prescott Joule. So, who is James Prescott Joule? He is an English physicist who established the various forms of energy. So, he is a physicist who contributed to the study of various forms of energy. Now, what are the sources of energy, or where can we find energy? Energy can be found in the sun. It can also be found in the wind and also in water. And yes, energy can also be found in your muscles. Did you know that energy cannot be created or destroyed? It can only be stored or transferred. Now, what do you mean by that? For example, we have here a rock on top of the mountain. The rock has potential energy that is waiting to be used, therefore, it has stored energy. Now, what will happen if the rock on top of the mountain falls down? The potential energy of the rock will be converted into kinetic energy. Another example, when the ball is moving, it has a kinetic energy. When the ball stopped on top of the mountain, it has a potential energy. Another example, a man riding a roller coaster. When the roller coaster is not moving, it has a potential energy. When the roller coaster moved, the potential energy was transformed into kinetic energy because it moved. Therefore, when a potential energy is converted into kinetic energy, we can also say that the stored energy is converted into motion energy. Now, we can say that energy can be classified into two. You have the potential energy and the kinetic energy. Again, from our examples a while ago, the potential energy is the energy that is stored and waiting to be used, while the kinetic energy is the energy of an object due to its motion. Now, what are the examples of potential energy? One of the examples of potential energy is the rock that is on top of the mountain. Another example of potential energy are the strings or a rubber band. And also, another example of potential energy is a battery that can light up a bulb. Potential energy has a symbol of capital letter P and capital letter E. The potential energy can be classified into three. We have the gravitational potential energy, the elastic potential energy, and the chemical potential energy. The gravitational potential energy is the energy due to an object's position. Like our example a while ago, the rock that is located on top of the mountain. While the elastic potential energy is the energy due to compression or expansion of elastic object. Like our example a while ago, the spring and also the rubber bands. And lastly, the chemical potential energy is the energy stored within the chemical bonds of an object. Like our example a while ago, the battery, which can light up a bulb. The potential energy is measured using the formula of PE is equals to mgh. Let us apply it in a sample problem. But before we proceed to the sample problem, let us first remember the following symbols that we are going to use. When you see a capital letter P and capital letter E, it is known as potential energy. While the small letter m stands for mass, small letter g stands for acceleration due to gravity, and small letter h stands for height. Another thing that we should remember are the following units that we will use for potential energy is capital letter J, which stands for joules. While the mass is kilograms, the G or the gravity is meter per second squared, while the H is meters. For example, if you see 10J, it means it is the potential energy. Another one, if you see 5 kilograms, 10 kilograms, it is considered as mass. While the gravity has a constant value of 9.8 meters per second squared, meaning to say, gravity is always present when we are finding the potential energy of an object. While the example for height is 7 meters, 9 meters, 10 meters, it in a sample problem. The problem states that what potential energy is acquired by a hammer with a mass of 0.75 kilograms when raised at 0.35 meters. Remember, in solving a problem, we use the GRESA method. Sample problem states that what potential energy is acquired by a hammer with a mass of 0.75 kilograms when raised at 0.35 meters. So in order for us to solve the problem, we are going to use the GRESA method. So let us first start with letter G, that stands for given. Let us find out all the given values or datas in the problem. The first one is the mass of 0.75 kilograms. The next one is the height of 0.35 meters and the constant value of 9.8 meters per second squared, which is the gravity, in which it is always present in solving the potential energy of an object. Next to the GRESA method is the letter R, which stands for required. So in the problem, the required is the potential energy. So we are going to look for the potential energy of the object. Next to GRESA method is letter E. So we're just going to use the formula for the potential energy in which PE is equals to mgh. Next to Gresa method is letter S, which stands for solution. So we're just going to distribute the given to the equation in which PE is equals to the mass of 0.75 kilograms multiplied by the gravity of 9.8 meters per second squared multiplied by the height of 0.35 meters. If we multiply all the given, our answer will be 2.57 joules. So the potential energy of the hammer is 2.57 joules. Another problem. A rock has a mass of 80 kilograms. The center of mass is 90 meters above the ground. How much energy does it have? So again, we are going to use the Gresa method in order for us to solve the problem. So let us find out what are the given values in the problem. The first one is the mass of 80 kilograms. The next one is the height of 9.0 meters. And the next one is the gravity or the constant value of gravity, which is 9.8 meters per second squared. So the next thing that we are going to use is the letter R, in which it is the required. So what is required in the problem? Again, it is the potential energy. Next to letter R in Gresa method is letter E, which stands for the equation. So again, we're just going to use the formula of potential energy, which stands for PE is equals to mgh. Next in the Gresa method is the letter S, which stands for solution, and so we're just going to distribute the given to the equation, in which PE is equals to 80 kilograms multiplied by the gravity of 9.8 meters per second squared multiplied by the height of 9.0 meters. If we're going to multiply all those values, our answer will be 7,056 joules. And so, the rock has a potential energy of 7,056 joules. Another example problem. The problem states that a 1.80 kilogram cat climbs 12 meters upward to sit on the roof of the house. How much potential energy does it possess while it sits enjoying the sun? So in order for us to solve the problem, again we are going to use the Gresa method. In the Gresa method, the first letter that we should know is the letter G, which stands for given. So we're just going to enumerate the given values in the problem. The first given is the mass of 1.80 kilograms. The next one is the height of 12.0 meters. And the last one is the constant value of gravity, which is 9.8 meters per second squared. Next to Gresa method is letter R, which stands for required. So again, what is required in the problem? So it is the potential energy. So we're looking for the potential energy. Next to Gresa method is letter E, which stands for equation. So the equation or the formula that we're going to use for the potential energy is again PE is equals to mgh. Next to Gresa method is letter S, in which we're just going to distribute the values of the given to the equation. So 1.80 kilograms, which is the mass, multiplied by the gravity of 9.8 meters per second squared, multiplied by the height of 12.0 meters, the answer will be 211.68 joules. So the cat has a potential energy of 211.68 joules. Now, how about the kinetic energy? What are the examples of the kinetic energy? So, kinetic energy is defined as an energy of an object due to its motion. Energy or kinetic energy is measured using the formula of Ke is equals to 1/2 mv squared, or kinetic energy is equals to mass multiplied by the velocity squared over 2. Now, what do we mean by squared? Velocity squared is that you're just going to multiply the value to itself. So just like our example here, 12 multiplied by itself, which is 12. So 12 times 12 is equals to 144 meters per second. So if you will see a squared in your sample problem, you're just going to multiply it to its own value. So again, remember the following symbols for kinetic energy. So capital letter K and capital letter E stands for kinetic energy, while the small letter M stands for mass and the small letter V stands for velocity. The following units that we are going to use in solving a problem in the kinetic energy are: again, for the kinetic energy, we're going to use the unit joules or capital letter J, while in the mass, we're going to use kilograms, and while for velocity, we're going to use meters per second. Example, if you see 10 joules, 5 joules, it is considered as kinetic energy. While if you see 5 kilograms, 10 kilograms, it is considered as mass. While if you see 7 meters per second, 5 meters per second, it is considered as velocity. Now let's apply it in a sample problem. Determine the kinetic energy of a 625 kilogram roller coaster car that is moving with a speed of 18.3 meters per second. So again, in order for us to solve the problem, we're going to use the Gressa method. The given in the problem are mass of 625 kilograms and the velocity of 18.3 meters per second. The required is the kinetic energy. The equation again for the kinetic energy is that mv squared over 2, which means mass multiplied by velocity squared divided by 2. So the solution is that Ke is equals to the mass of 625 kilograms multiplied by the velocity of 18.3 meters per second squared over 2. So the answer will be 1.05 times 10 raised to 5 joules. So another sample problem. So for you to easily understand the kinetic energy, here is another example problem. The problem states that Joey weighs 8.2 kilograms and runs with a speed of 4.0 meters per second. What is her kinetic energy? So in order for us to solve the problem, we are going to use again the Gressa method. The given in the problem are 8.2 kilogram, which is mass, and the velocity of 4.0 meters per second. The required in the problem is the kinetic energy. So we're going to look for the kinetic energy. While the solution or the equation that we're going to use for the kinetic energy is that Ke is equals to mv squared over 2. The solution is that we're just going to distribute the given into the equation, and so Ke is equals to the mass of 8.2 kilograms multiplied by the velocity of 4.0 meters per second, which will be squared and will be divided into 2. So the answer will be 65.6 joules. So meaning to say, Joey has a kinetic energy of 65.6 joules. Another problem. A 2.0 kilogram object is traveling at 4.0 meters per second. Calculate its kinetic energy or Ke. So again, in order for us to solve the problem, we're going to use the Gressa method. Now, what are the given in the problem? We have the mass of 2.0 kilograms and the velocity of 4.0 meters per second. Next is letter R, which is the required. So, what is the required in the problem? Again, it is the kinetic energy. Next is letter E, which is the equation. So, what will be the formula for the kinetic energy? We have Ke is equals to mv squared over 2. Next, for the letter S, we have the solution. We're just going to distribute the given into the equation, and so Ke is equals to 2.0 kilograms, which is the mass, multiplied by the velocity of 4.0 meters per second, that will be squared, over 2. So the answer will be 16 joule. So the object has a kinetic energy of 16 joules. Assignment for today: answer the learning task in your module assigned to your classwork for this week and also your learning activity sheets. So that ends our discussion for today. I hope you will learn something new and see you again in our next meeting. Goodbye!